Good nutrition is crucial for athletes, providing essential nutrients for general health, growth, and development, as well as the energy needed for training, competition, and mental focus. Proper nutrition supports muscle repair and building, helps decrease the risk of injuries and illness, maximizes training adaptations, the improvements achieved from training, and assists athletes in reaching their performance goals. This chapter explains the scientific foundation for performance-enhancing nutrition practices and offers practical suggestions to help apply sports nutrition science in real-life scenarios. The sheer volume of nutrition information, often conflicting, circulated through the internet, print media, and word of mouth can be overwhelming for athletes, making nutrition a confusing subject. Additionally, each athlete's dietary requirements differ significantly from those of age and sex-matched sedentary individuals due to the physiological demands of their sport. General nutrition guidelines intended for the public may not be applicable to athletes. Athletes' nutrition needs vary greatly depending on factors like age, body size and composition, sex, genetics, environmental training conditions, injury history, medical nutrition needs, and training details such as duration, frequency, and intensity. As a result, nutrition needs can differ widely even among athletes playing the same position. Moreover, because nutrition science is complex and constantly evolving, strength and conditioning professionals need basic nutrition knowledge and a list of qualified nutrition professionals to whom they can refer athletes for individualized advice based on the latest scientific evidence. Role of sports nutrition professionals. Sports nutrition is a complex, multidisciplinary field. Athletic trainers, strength and conditioning professionals, physicians, exercise scientists, and food service providers possess different levels of nutrition knowledge. The roles and responsibilities of player development staff should be clearly defined based on each member's level of nutrition training, the type of nutrition information they provide, and the state licensure laws governing nutrition practice. All members of the sports nutrition support team should be able to answer fundamental nutrition questions such as what are some healthy snack ideas. However, athletes with more complex nutrition needs should be referred to specialized professionals like team physicians or sports dietitians. The team physician oversees the athlete's medical care, while the sports dietitian provides individualized dietary advice. A sports dietitian is a registered dietitian or registered dietitian nutritionist with specific training and experience in sports nutrition. The Academy of Nutrition and Dietetics Board Certified Specialist in Sports Dietetics, CSSD, credential distinguishes dietitians with expertise in sports nutrition from those specializing in other areas. While some sports dietitians have additional skills such as social work, athletic training, or culinary expertise, a comprehensive sports nutrition program requires full-time attention to sports dietetics. Therefore, these secondary skills are complementary and not a replacement for the specialized knowledge a dedicated sports dietitian offers. For advanced positions in sports nutrition, a master's degree or PhD may also be required. Sports dietitians help athletes connect dietary habits to performance outcomes. In certain cases, physicians and sports dietitians collaborate to support athletes dealing with eating disorders, nutrient deficiencies, or specific medical conditions like diabetes. because nutrition and medical information may need to be shared with other members of the player development team, coaching staff, or family members to provide comprehensive care. In the United States, all team members are required to follow Health Insurance Portability and Accountability Act guidelines to protect the athlete's private information. A sports nutrition coach is someone who is not a registered dietitian but has foundational training in both nutrition and exercise science. Strength and conditioning professionals, for example, can take on the role of sports nutrition coach, offering basic nutrition education and guidance. More complex cases, such as when food or nutrition is being used to treat or manage a medical condition or nutrient deficiency, require medical nutrition therapy provided by a sports dietitian. Sports nutrition coaches can further their knowledge by obtaining certifications, such as the American Council on Exercise Fitness Nutrition Specialist certification, designed for personal trainers, health coaches, and fitness instructors. The International Society of Sports Nutrition also offers a sports nutrition specialist certification for those with a high school diploma, which is aimed at fitness professionals. For more advanced professionals, the ISSN provides the Certified Sports Nutritionist (CISSN) credential, which requires a bachelor's degree in a relevant field or a current enrollment in an exercise science, nutrition, or related program. Another option for advanced training is the International Olympic Committee Diploma in Sports Nutrition, a 2-year program that includes coursework, seminars, tutorials, and lab practicals designed for professionals working with athletes. A sports nutritionist with an advanced degree might work in the sports nutrition industry or conduct research, providing insights on specific topics in sports nutrition. Sports nutrition professionals are required to adhere to state licensure laws, which differ from state to state and define who can provide individualized nutrition counseling and medical nutrition therapy. For instance, in Louisiana, general nutrition education can be offered by various professionals if the information is general and accurate. However, only licensed dietitians or nutritionists can provide individualized nutrition assessments and counseling. Nutrition counseling is defined as offering personalized advice on food and nutrient intake for people with special needs, factoring in health, culture, socioeconomic status, functional capacity, and psychological needs. Counseling may include recommending nutrient adjustments, meal timing and composition, and in rare cases, changes in the route of administration. Strength and conditioning professionals should carefully evaluate any sports nutrition professional's qualifications, examining their education, work history, sports nutrition expertise, and years of experience. Experienced sports dietitians help athletes make the connection between dietary habits and performance outcomes, leveraging their advanced knowledge and expertise in sports nutrition. The first step in nutrition coaching is to clarify the athlete's goals and the coach's goals, which may differ. Then, similar to how a strength and conditioning professional performs a needs analysis, the sports dietitian conducts a thorough assessment of the athlete's diet, food preferences, including cultural and religious considerations, cooking skills, food access, financial constraints, obstacles to healthy eating, supplement use, weight and body composition history, medical history training program, and injury status. This comprehensive analysis enables the dietitian to create a personalized plan that fits the athlete's lifestyle and food preferences while ensuring an appropriate calorie level, proper macronutrient and micronutrient intake, adequate fluid and electrolyte balance, and targeted supplements to correct nutrient deficiencies, fill dietary gaps, or support training goals. For general nutrition guidance, strength and conditioning professionals might direct athletes to MyPlate, a resource from the U.S. Department of Agriculture, USDA, based on the dietary guidelines for Americans. MyPlate is a visual representation of 5 food groups: fruit, vegetables, grains, protein, and dairy, arranged like a plate setting to help individuals make healthier food choices. MyPlate website includes calorie and portion recommendations tailored to age and sex for people engaging in less than 30 minutes of daily physical activity, as well as guidelines for oils. Although oils are not a food group, they provide essential nutrients like essential fatty acids and vitamin E. Physically active individuals may need to adjust these recommendations to meet their energy demands. MyPlate can serve as a helpful starting point, but athletes often require a customized nutrition plan that goes beyond these basic guidelines. Eating a variety of foods within each food group helps ensure athletes meet their nutrient needs. For example, eating a mix of fruits like apples, oranges, and berries offers a broader nutrient profile than consuming just one type of fruit. Athletes who avoid certain food groups, such as dairy, may require additional guidance to fulfill their needs for nutrients like calcium, potassium, and vitamin D. Similarly, those who exclude all animal products might need help sourcing adequate vitamin B12, which is naturally found in animal-based foods. Sports dietitians assist athletes in finding suitable alternatives to ensure they meet their nutrition needs for health and performance. The Super Tracker tool on the MyPlate website includes sample meal plans based on caloric needs, guidance on empty calories, food labels, and options for tracking food intake, physical activities, and weight, helping users monitor their progress toward dietary goals. The dietary reference intakes are a comprehensive set of nutrient guidelines developed by the Food and Nutrition Board of the Institute of Medicine under the National Academies. The dietary reference intakes help in evaluating and planning diets for healthy individuals and cover essential nutrients, including macronutrients, micronutrients, electrolytes, and water. Unlike previous guidelines that focused only on preventing nutrient deficiencies, the dietary reference intakes are based on an extensive review of literature examining nutrient intake and its role in reducing chronic disease risk. Since nutrient intake can vary day to day, the dietary reference intakes are intended to reflect an individual's usual intake over a period of days rather than a single day. This approach is particularly important for nutrients that are either found in limited foods or in small amounts. The DRIs consist of several categories. The recommended dietary allowance, RDA, this is the average daily intake level needed to meet the nutritional needs of most healthy individuals in a particular age and sex group. RDAs are set based on scientific evidence and are designed to prevent deficiencies. Adequate intake, AI, this is the recommended average daily intake level that is assumed to ensure nutritional adequacy when an RDA cannot be established due to a lack of sufficient data. Tolerable upper intake level, UL. This is the maximum daily intake that is unlikely to cause adverse health effects. Consuming nutrients above the UL increases the risk of negative effects. The UL considers intake from all sources, including food, water, and supplements. Estimated average requirement, EAR, this is the average daily intake level estimated to meet the needs of half of the healthy individuals in a particular age and sex group. EARs are often used as a basis for calculating the RDA. Despite these guidelines, studies highlight that several nutrients are often underconsumed, posing public health concerns. Certain nutrients have been identified as particularly problematic due to widespread inadequacies across various population groups. Vitamin E and magnesium. There is a high prevalence of inadequacy in vitamin E and magnesium intake across nearly all age and sex groups. Vitamin E is abundant in oils, nuts, and seeds, while magnesium is found in foods such as pumpkin seeds, almonds, cashews, and beans like mung beans and lima beans. Fiber and potassium. The average intake of fiber and potassium is below recommended levels in individuals over the age of 2. The 2015 Dietary Guidelines Advisory Committee lists these nutrients as critical for health. Sources of potassium include fruits and vegetables, while fiber-rich foods include whole grains, fruits, and legumes. Calcium and vitamin D, these are also highlighted as nutrients of concern. Calcium is found in dairy products, fortified beverages like soy and orange juice, and canned fish with bones such as sardines. Vitamin D is available in fatty fish, fortified milk, orange juice, and yogurt. Both nutrients are essential for bone health and immune function. Iron. Iron deficiency is a particular concern for women and adolescent females who may become pregnant, as iron needs are higher in these groups. Red meat, iron-fortified cereals, and legumes like beans are excellent sources of iron. Folate. Folate intake is also inadequate in some groups, particularly women of reproductive age. Key sources include beans, peas, peanuts, and seeds like sunflower seeds. Vitamin B12, though vitamin B12 is no longer listed as a general nutrient of concern, its absorption decreases with age due to reduced stomach acid production in around 10 to 30% of older adults. Therefore, adults over 50 are encouraged to consume B12 fortified foods or supplements for better absorption. Animal-based foods like beef, lamb, veal, and fish are excellent sources of B12, as well as fortified cereals and nutritional yeast. In practical dietary planning, while athletes and the general population eat whole foods rather than isolated nutrients, understanding the dietary reference intakes allows for tailored food recommendations that meet specific nutrient requirements. For sports dietitians or strength and conditioning professionals, these guidelines offer a foundation for recommending diets that support health, performance, and recovery. However, individualized advice should be based on an athlete's unique needs, and more complex cases should be referred to qualified sports dietitians who can incorporate these dietary reference intakes into detailed dietary plans, ensuring athletes receive adequate nutrient intake for optimal health and performance. Macronutrients are essential nutrients that must be consumed in significant quantities to support bodily functions and energy needs. The three primary macronutrients are protein, carbohydrates, and fats, each serving distinct roles in supporting health, growth, and physical performance. Protein is the foundational, structural, and functional component in all cells of the human body. It is essential for growth, development, and repair of tissues and plays multiple roles, including acting as enzymes, transport carriers, and hormones. Protein is especially important for maintaining health and cellular function. Proteins are composed of amino acids which contain carbon, hydrogen, oxygen, and nitrogen. There are 20 amino acids that combine to form the various proteins in the body. These amino acids are categorized into three groups: non-essential amino acids. These can be synthesized by the body and include 4 amino acids. Essential amino acids. These 9 amino acids cannot be produced by the body and must be obtained through the diet. Conditionally essential amino acids. these are typically non-essential but become essential during times of illness or stress. Amino acids are connected by peptide bonds, with two amino acids forming a dipeptide, several forming a polypeptide, and complex polypeptide chains forming complete proteins with various functions. About half of the body's protein reserve is in skeletal muscle, with the rest in structural tissues like skin, blood, and visceral organs such as the liver and kidneys. The quality of protein is determined by its amino acid content and digestibility, specifically its nitrogen absorption and ability to support growth and repair. Animal-based proteins like eggs, meat, fish, dairy generally contain all essential amino acids, making them high-quality sources. Soy is one of the few plant proteins that provides all essential amino acids. In general, plant proteins are less digestible than animal proteins, though digestibility can be enhanced through food processing or preparation. Factors in foods called anti-nutritional factors can inhibit protein digestion and absorption, making some amino acids less available for the body's use. For instance, the Maillard reaction, which occurs during browning of certain foods, can reduce amino acid bioavailability. However, individuals following vegetarian or vegan diets can still meet their protein needs by consuming a variety of plant foods such as legumes, seeds, nuts, and whole grains to ensure they get all essential amino acids. Protein requirements vary based on an individual's activity level and health goals. For adults aged 19 and older, the recommended dietary allowance for protein is set at just under 1 gram per kilogram of body weight daily. Protein needs are generally higher for children, teenagers, and women who are pregnant or breastfeeding. The acceptable macronutrient distribution range for protein intake also varies by age group. For young children between the ages of 1 and 3, protein intake should make up between 5 and 20% of total daily calories. For older children and teenagers from ages 4 to 18, protein should account for 10 to 30% of daily calories. For adults over the age of 18, protein intake is recommended to fall between 10 and 35% of total daily calories. When calorie intake decreases, the percentage of calories from protein should increase to ensure the body meets its protein needs. For athletes, protein recommendations are more specific to support the demands of training and recovery. Aerobic endurance athletes are advised to consume between 1 and 1.5 grams of protein per kilogram of body weight each day. Strength athletes typically need slightly more, ranging from 1.5 to nearly 2 grams per kilogram of body weight daily. Athletes who train with a combination of strength and endurance activities are also recommended to consume between 1.5 to nearly 2 grams per kilogram of body weight daily. Protein needs may increase further for athletes who are on a calorie-restricted diet to help prevent muscle loss during weight loss. Consuming protein immediately after exercise can help enhance muscle protein synthesis and repair. After exercise, muscle sensitivity to amino acids increases, allowing protein to aid in muscle repair and growth more effectively. The general recommendation after endurance exercise is a 4 to 1 or 3 to 1 ratio of carbohydrate to protein. After resistance training, 20 to 48 grams of protein, depending on factors such as age and leucine content, can help maximize muscle protein synthesis. Research generally indicates that protein intake above the dietary reference intakes does not harm healthy individuals. In cases of excess protein intake, the body breaks down the surplus, excreting nitrogen as urea and converting the remaining compounds into energy or fat. Studies have found that even protein intakes up to 2.8 grams per kilogram body weight do not negatively impact kidney function in healthy individuals. However, for balanced nutrition, strength and conditioning professionals should ensure that excessive protein intake does not come at the expense of adequate carbohydrate and fat consumption, which provide essential nutrients found in these food groups. For athletes, protein intake of 1 to 1.7 grams per kilogram body weight is generally adequate for building and repairing muscle, depending on the demands of the sport and training program. Athletes generally need a higher protein intake than the standard recommended dietary allowance to effectively support muscle building, repair, and maintenance. For endurance athletes, the suggested protein intake ranges from 1 to 1.5 grams per kilogram of body weight daily. Strength athletes often require slightly more, typically between 1.5 to just under 2 grams per kilogram each day. Those who participate in mixed modality training, combining elements of both strength and endurance, are also recommended to consume around 1.5 to just under 2 grams of protein per kilogram of body weight daily. By customizing protein intake to meet individual requirements and focusing on both the total daily amount and the timing of consumption, athletes can better support their training efforts, optimize recovery, and enhance their overall health.